I'm going to break this up into two pieces. And again, this is an example where it's very important to have the PowerPoint open while you're watching the video so that you can advance the slides as you want to and make use of the pause button in the video. There's going to be several times where I'm going to give you an opportunity. I'm going to go through an example and then give you an opportunity to try it on your own. And so that would be a good time to hit pause. I'll even say hit pause, and of course I'm only going to wait a few seconds, but you can hit pause and try things on your own. You should have your periodic table out while you're working on this, that kind of stuff. All right, so let me just go ahead and get started. We're going to go through, and some of this, a lot of this we've actually done, but I'm going to remind you of it. We're going to put this back, put some of this stuff together. All right, so this is nomenclature really for ionic compounds, but we've done covalent compounds, but I've got it in the slides. I'm going to go through those ones quickly because we've done it, but we haven't gone through nomenclature of ionic compounds. Remember, ionic compounds are made from ions, so they're typically a metal and a nonmetal. What I would suggest you do is from the PowerPoint, perhaps print this slide only and use this flow chart, because everything is really going to be to go, all the other slides are how to use this flow chart. All right, so basically there's three types of compounds actually in terms of nomenclature, ionic and covalent. We're not going to address acid nomenclature in this class, but there actually are three types. Covalent compounds we've talked about, ionic is the new thing here. And this applies because we're going to be talking about water, and ionic compounds are very involved in water chemistry. All right, so again, ionic and covalent, this is the top of the flow chart. So ionic compounds contain a metal or a polyatomic ion. Covalent compounds we've talked about. So just going from name, we're going to go name to formula, and then the second video will be formula to name. So the idea here is to go from name to formula. How do I know that the compound is ionic? And as the flow chart said, okay, they contain a metal or a polyatomic ion. So you know how to find metals on the periodic table. You would use the periodic table to find the symbols, and then remember on the periodic table, they're to the left and below the stair step. Polyatomic ions, there are 6 I need you to know for this class. So hydroxide, a polyatomic ion is an ion made from more than one atom. Poly is a prefix that means many. Right, so you should memorize these 6. Hydroxide is OH minus, so remember the charges. Ammonium is NH4 with a positive charge. Sulfate is SO4 with a -2 charge. Nitrate, NO3 with a -1. Phosphate, PO4 with a -3. And carbonate is CO3 with a -2. And you'll notice 4 out of the 6 end in 8. All right. So just for examples, we know this is an ionic compound because strontium is a metal. Cesium phosphate, we have 2 clues that this is ionic because cesium is a metal, phosphate is a polyatomic ion, and ammonium sulfate is made from 2 polyatomic ions. All right, covalent compounds we'll do quickly. Covalent compounds, if you recall, we did nomenclature of these very early in the semester. They're made from 2 nonmetals. And you just get the sense. So how do we know? We get the symbols from the names, right? Carbon disulfide has carbon and sulfur. Remember, nonmetals are on the right-hand side above the stair step on the periodic table. Sulfur hexafluoride, sulfur and fluorine are both nonmetals, so it's a covalent compound. Dinitrogen pentoxide, again, you have nitrogen and oxygen. Right? So you can try these on your own. This is a good place to hit pause. If you're playing on the slides, if you click on the answer slide, it'll take you to a slide that's answers. Just make sure you use the back button on the answer slide so it will take you back to where you're going. So try these on your own. Hit pause on the video. I'm going to count to about 10, and then I'm going to keep going, but hit pause. Try them on your own. All right, hopefully you tried them on your own. So now I'm going to show you to hit the answer slide. Whoops, I went the wrong way. What did I just do? All right, so we hit the answer slide. Okay, so ammonium sulfide, we know it's ionic because it contains a polyatomic ion. Cesium chloride, again, we have an ionic compound because cesium is a metal. Nitrogen triiodide has nitrogen iodine, therefore it is covalent. So make sure you hit the back button, it'll take you back to the slide we left off on. All right, now how do we come up with the formula of an ionic compound? Well, the trick is we have to get, the bottom line is you want to get the symbols, you want to get the charges, and then put the ions together. All right? And so first thing, how do we get the charges? We've actually gone through this, so this should be a review. All right? There's really 3 types of ions in this class. There's metal ions, there's non-metal ions from the periodic table, and the polyatomics. Polyatomics you just got to memorize. All right? So the metals, the nonmetals, and then the polyatomics. And you can use the flow chart. So the representative metal ions, and technically for this class, we're not going to deal with what are called the transition metals. We just don't do that in Chem 111. It's not important chemistry to what we do. All right, but so groups 1, 2, 13, and then zinc, cadmium, and silver. And remember, we did this before. The charge will be the group number that's in the ones place. So barium is in group 2. Its charge is +2. Aluminum is in group 13, so it's a 3 in the ones place. Its charge is +3. I'm doing this quickly because we've done this. Zinc is in group 12, so it's the 2 is in the ones place. It's a +2. So try these on your own. Okay, I'll hit pause. All right, I think you're back from pause now, so you can go through these. Calcium, it's in group 2. It's a +2. Cadmium is in group 12, okay, so it's a 2. Potassium is in group 1. So all these groups, remember, are on the periodic table. So again, this is review. We've done this before. All right. So now, what about the nonmetal ions? We've done this as well. So the nonmetal ions, you can take the number in the ones place and subtract 8. First thing you have to do, though, is know that it's a nonmetal. Remember, nonmetals always have negative charges. So oxide is from oxygen. It's in group 16. It's a -2. Phosphide is from phosphorus. It's in group 15. It's a -3. Iodide, is from iodine, which is in group 17. All right? So try these on your own. Hit pause. All right, back from pause. Again, I'm doing these quickly because we've done this before. I think we even had a homework where you were asked about this. All right, so just make sure you can come up with each of the charges. Sulfide will be a -2. This is the reasons. Nitride, just finding them on the periodic table. We've talked about this before. Chloride, carbide, okay? All right, so now, the polyatomic ions, again, I gave you these ones, so make sure you memorize them. Okay, I switched the order here. Maybe print this slide as well, or just write them down. There's only 6. Okay. Now, to put the ions together, the bottom line is an ionic compound is made from ions, but the compound has no net charge, so we have to make everything cancel out. So what we have to do, and we have to make the charges cancel. So we are going to take them and put some multiplier to bring the charges to the least common multiple. That multiplier becomes the subscript. All right, so for example, a compound from aluminum and sulfate. So aluminum is Al with a +3, sulfate is a -2. That means we need to get the charges each to 6 to make this cancel. That means we're going to need 2 of the +3s and 3 of the -2s. These 2 numbers here become the subscripts. Now, because we have 3 of a polyatomic ion, the polyatomic ion has to be in parentheses, so it's 3 SO4s. You can see if we didn't have the parentheses, it would look like there's 43 oxygens, and obviously there are not. All right. So I'm going to do this example, and then I'm going to have you do one, and then I'm actually going to break this into 3 videos. I don't like the videos to be too terribly long. All right. So try these on your own. Oh, no, I'm going to go through these, excuse me. So get the symbols, right? Potassium sulfide. So it's potassium is a K, sulfur is an S. Then we get the charges. Potassium is a metal in group 1. It's a +1. Sulfide is from sulfur. It's a nonmetal. It's in group 16. 6 minus 8 is -2. That means we need to get the charges to 2, so we need 2 potassiums and 1 sulfide. We don't write the 1. Okay. For calcium phosphate, okay, there's Ca and PO4, calcium and phosphate. Phosphate, we know the charge because we memorized this one. So calcium, to find the charge, we say it's a metal. It's in group 2. therefore it's A plus 2. And then, of course, that's a polyatomic ion. So here, we need to make the charges cancel. We have to get to a 6. So we're going to need 3 of the calciums and 2 of the phosphates. And so we're going to write it Ca subscript 3, PO42. And then for ammonium nitrate, okay, these are both polyatomic ions, NH4NO3, right? We need 1 of each. So we write it like this. We don't write N2H4O3. We write it this way because that way you can tell it's made from polyatomic ions. All right, I'm going to let you try these on your own. I'm going to stop this video here, and then video number 2, we'll go through the answers to these.